Hi friends, it's Mrs. Baxter again, and we are continuing with part 2 of the compound inequality. So last time we talked about and statement. So the two inequalities both had to satisfy the and requirement in order to be, in order to be a solution. Well, today we are going to look at or. So in this case, a compound inequality using or is true if either simple inequality is true. So they don't both have to be true this time. Okay, so we are looking at or statements today. And it's true if either is true. Doesn't have to be both. So let's look at this. This is going to go a lot faster today. Let's determine again whether 5 satisfies each compound inequality. Last time we looked at 5, but it was an and statement. Okay, so does 5, let me do this again. Does 5 satisfy each compound inequality? On B, it says x is less than 6 or x is less than 8. So we're going to plug in 5 for x. And we're going to have 5 is less than, I'm going to zoom in a little bit here. 5 is less than 6. Well, that's true. And 5 is less than 8. Yep, that's true. So yes, we do have an or statement that satisfies. Both of them happen to be true, but it doesn't matter because we just need one or the other one. All right, let's look at the other one. This time, last time we solved for x. This time we're just going to plug in 5. Here we're going to plug in 5 here and see what happens. So 2 times 5 minus 9. Well, that's 10 minus 9, which is 1 is less than 5. Right? Okay, is 1 less than 5? Yes, it is. Okay, but now let's see. Negative 20 is greater than negative 12. I would say yes. I would say no, this does not apply because negative 20 is definitely less than negative 12. Remember, on our number line, we have negative 12. That's terrible. 12. Negative 12, and somewhere down here we have negative 20, and so we know that these numbers are bigger, so this does not ring true, but it doesn't matter because this is an or statement, right? And since we have an or statement and one of these is true, we do have a solution. Yes. Okay. Only one of them applies. All right, let's do some graphing. Let's graph this or statement. And I have negative 2 is less than x. Well, let me find, here's negative 2. I'll just put it down here. Here's negative 4. And I have an open circle and an open circle for both of them. And let me think, x is greater than negative 2. So I'm going this direction, okay? And I'm going, x is less than negative 4. So I have to go this direction. Well, I'm just graphing them. What this is saying is that x can be either, okay? X can be either this or this, okay? Let's look at the next one. 14 is less than x. Let's just say here's 0, here's 14 somewhere. This is not to scale, obviously, people. But we have open circle. X is less than x, right? Oh, no, sorry. 14 is less than x. What am I thinking? 14 goes this way, so we've got solutions this way. Or x is less than 0. Again, we have something very similar. X can be either this or that, right? This or that solution. Okay, for it to be true. So when we actually look at these equations, now you're gonna have to do a little bit of manipulating, okay? Pay attention to your statement right here, or, and let's solve. All right, so I have minus 3. I'm going to subtract 3 from both sides. I have 2x is less than or equal to 6. If I divide by 2 on both sides, x is less than or equal to 3. Okay, so let me graph that. Let's see, I have a 3 here. Let me see what that looks like. Let's see, well, actually, you know what? You don't want to graph it yet until you've done the other side. So let's do the other side really quick. And I have 3x is greater than 18. Divide both sides by 3. X is greater than 6. Okay, now I can graph it because I know what my two numbers are. Silly me. All right, so x is 6. Let's do that. 3 is here. 3 is a closed circle, and 6 is an open circle. And x is less than 3, so we're going to go in this direction. Everything below 3 qualifies, and then x is greater than 6, so everything above 6, not including 6, but above 6 is the answer. Okay, and then let's look at this one. Again, we are looking to satisfy this or. So one of these just has to be true, but also we're just looking for possible solutions for one or the other. All right, so I'm going to move this over. I'm going to have 3 is less than negative x. Oh, what do I need to do? Divide by -1, which means I have to flip my sign. 3 is greater than x. Did I mess something up? Okay, let's look at this. Maybe I messed something up. Hopefully I didn't. -5 minus 5. 2x is greater than or equal to 6. Divide by 2. X is greater than or equal to 3. Okay, so we have 3 at both spots here. I feel like I did something. Oh, I see what I did. Yikesies. So if I'm dividing, what did I do? Nope, I did that right. Here's where I messed up, you guys. I forgot. This is a -3. I knew something looked funky on this. You have to say, Mrs. Baxter. 1, 2, 3. Okay, so now I have -3 is greater than x. So x is less than, sometimes I read it backwards, right? X is less than -3. So we're going this direction. All of these apply. Circle in because it includes that. X is greater than. Voila, there you go. All right, and then obviously we have special cases. All right, let's look at our special cases really quick and then we'll be done. All right, special cases. X is greater than or equal to 3. So here, let's put 3 here, 4, 5 here. X is greater than or equal. Okay, so we have a closed circle because it includes it, and x is greater than, okay? But then x is also greater than or equal to 5. Oh, look at that. So everything from here, this is an or, right? So this could be true, or this could be true. So in the or case, you're going to also include all of these solutions. We didn't do it before because it had to be both of them but this is an or, okay? So this particular graph represents this solution. X is really greater than 3. All of those possible solutions apply in this case. Let's look at the second special case. Okay, in this case, we do have to do a little solving. So let's solve for this. X is greater than or equal to -9, or -5x is greater than or equal to 30. I'm going to divide by -5. Oh, dividing by negative, we have to flip the sign. So x is less than -6. All right, so I've got these two numbers I've got to solve or put on the graph. Okay, that was terrible. Better. All right, so I have -6, 8, -9. -9 is a solid, and -6 is an open circle. Okay, and then I have -6 is x is less than it, right? And then with negative 9, x is greater than, oh, wow, look at that. Guess what? This whole thing, this graph says that all real numbers, the hashtag sign means numbers, people, are the solution, okay? The other symbol you could do is this, all real numbers, okay? They both are the same. Okay, so those are all of your possible solutions for compound inequalities that are or statements. All right, let's go ahead and switch over to the homework. If you have any questions about anything that I did, or you saw that I made a mistake, you know, because that happens sometimes, come find me, talk to me. All right, you guys got this. I will talk to you soon.